Hi there, and welcome to our second week of semester 2. Just as a notice or a reminder, if you've already seen it, your semester 1 guided notes, the PDFs, are always going to be available in Google Classroom going into the classwork materials. So if you want to use that to study, if you want to use that to remind yourself, look at some old content, that will always be there. If you want to see some of the old videos, Google Classroom doesn't let me attach every single one of those videos to one post. So if you're interested in an old video, please just reach out and I'll send you the link separately. Today we're going to keep going with Chapter 7, and we're going to talk about converting with scale drawings, such as the map we see here. And you have homework from 7.7. So get yourself ready for notes, and we're going to get started. Now, one thing that is an important thing that I want to remind you of, you've mostly been doing super great about this. I just want to make sure that we're all on the same page here with our metric conversions. Your science teachers have clearly been doing a great job, and you've been working really hard to practice these. But just as a quick reminder, 1 meter here is equal to 100 centimeters. You could also then express that as 1 centimeter is 1/100th of a meter. 1 centimeter, you can think about this as 10 millimeters. Sometimes I see students convert back to meters and then back down. Centimeters to millimeters, just 1 to 10. And then 1 meter is 1,000. Oops, sorry, that's the wrong way around. 1 kilometer is 1,000 meters, which you could also write as 1 meter is 1,000th of a kilometer, like so. Now, one thing that you'll often be asked to do with scale drawings is estimate. And I want to walk through a couple ways to do that, even if you don't have a calculator or a ruler. Sorry, not a calculator, a ruler. So you're given the scale here, and it says estimate how far Seattle is for Denver. So if I don't have a ruler, which I don't on the screen, what I'm going to do instead is draw the line between Seattle and Denver to start. So here's Seattle in Washington State, down to Denver. And I'm going to draw the line there. And then what I would do is that if I had a piece of paper, I would measure this distance and just draw a little mark here on the piece of paper so that I have a scale of this long. And then I'd place it down on here, and I would count out how many times we get to 500. And if I do that, there's a 500 for there, move my little piece of paper, move along, and get another 500 here. So that's the length of this scale along here. And if I don't have a ruler, like I said, I'll just use a little piece of paper and mark it with a pencil. So then I know that this is going to be 500 to start with, plus 500. For the first two, and that takes us almost to Denver, but we still have this small piece left. And I'm going to estimate that. I can also add in these markers in between, since this whole thing is 500 and it's divided into 1, 2, 3, 4, 5 pieces. I know each of these segments is 100 miles, and that's approximately equal to what we have right here. And since this is an estimate, that means that we're not going to have all exactly perfectly the same numbers, but we'll have something that's plus, it's a little bit less than 100, so maybe I say plus 60, plus 50, plus 80, depending on your estimates. Hopefully what we would all end up with is similar amounts here, and then this might be the one that's more of an estimate. So we say approximately equal to, like that, 1,000 for the 500 plus 500, and 60 or 50, however you would like to express it, and don't forget your unit. Now you also might not have a picture, you might just have a description of the map. So here it says, on a map, 2 millimeters shows the size of a city 32 kilometers across. On the same map, 2 cities are 32.5 centimeters apart. How far apart are they in reality? So how far apart are the cities? So the way I like to set this up is to think about ratios, scales, and proportions. So we know that on the map, 2 millimeters turns into 32 kilometers. Now the question here is on the map again. So this is always your map. And this is reality, so scale and actual. Then we have 32.5 centimeters. And here's our unknown, kilometers. Now, what I like doing here is, I can just set this up as a proportion, set them equal, and you can use that to solve for x, just like with cross multiplying. The only issue is that when I set this up as a proportion, I end up with 2 millimeters over 32.5 centimeters is equal to 32 kilometers over x kilometers. So in this case, it's nice, kilometers cancel. Here we have millimeters and centimeters, so we have to convert them. I think it's easy to just move this decimal over one space, which turns them from centimeters to millimeters, using our conversion from here, just one space over, multiply by 10. And then we have the same unit which cancels, so the proportion we end up solving is 2 over 325 is equal to 32 over x. Now, when I cross multiply, I end up with 2x is equal to 32 times 325. I don't necessarily want to multiply that by hand without a calculator, so I'm going to divide by 2 right away, which at least simplifies this down to 16. Now, I could use a calculator here, or I could be sneaky. And I know that 16 times 325 is going to have a factor of 4 for 16 and 25 for 325. So that would be 4 for every 300 for 300, so that's 12 plus 1 more, 13. And this is just a nice sneaky trick because multiplying those together is 100, which is very nice and easy to multiply because now we have 100 times 13 times 4. 4 times 13 is 52. And then the 100 with the 2 zeros on the end. And don't forget your unit, kilometers. So there you have it. If you have questions about scale drawing, anything going into semester 2, or any of the materials wrapping up from last week, please let me know.